Hello everyone. Welcome to section 9.4 of chapter 9 of nuclear radiation. We're going to look at a really interesting concept right now about half-lives, and this is how we measure activity often. What you're seeing right here is an archaeologist, and the reason that you're seeing that is because a lot of times they use half-lives of elements in order to try to estimate the age of things that are extremely old. So the half-life of a radioisotope is the time that takes the level of radiation to decrease or decay 1/2 of the original value. Okay? So in the case that you're looking at right here, we can tell that the half-life of this material is 8 days, because each time it goes 8 days time, it gets half. And so we call that half-lives. And so the decay curve for this, which is I-131, shows that it has an 8-day half-life, okay? Because if you started out with 20 milligrams at time 0, then you'd have 10 after 8 days, and then 5 after 4 days, and then 2.5 after 16 days, and then 24 days, and then 32 days, and each time you would get half. Okay? And so this would be 1 half-life, 2, 3, 4 half-lives would be after 32 days. Now that's the big part of what you're going to be using this section for. So there are naturally occurring radioisotopes, as we've already seen. Carbon-14 is one of those that they use in archaeology to figure out long periods of time. The half-life of carbon-14 is estimated to be 5,730 years, and it is a beta emitter. So it's not just hugely dangerous to use. Potassium-40 is a beta gamma, and radium, strontium, uranium, they're all alpha emitters, which are pretty strong. The ones that we use in medicine, some are gamma, okay, and radon itself is an alpha emitter. But primarily gammas or betas we use. And notice the thing about these guys. Their half-life is in days. These are in what? Years. Okay? So we want something with a short half-life to use in the body, because that way the radiation decreases quickly. Okay? So if it has a short half-life, it will decrease quickly. And that's important because we don't want that radiation to hang out in our body. So when we use our half-lives, what we're going to do is we're being given needed in quantities, so we're going to be calculating some things, write the plan, write the half-life equality, and I'll show you how to do that, of course, and then set up that problem. So an example of this is you have a radioisotope of strontium-90. What's that tell you? It's got 90 mass, right? It has a half-life of 38.1 years. If a sample has 36 milligrams of this stuff, how many milligrams will remain after 152.4 years? Okay, and it's a lot of numbers, but it's really not that hard. What you're given is, you're given 36 milligrams to start with. You're given how long it's got, and you're given the half-life in the same units, okay? And what you want to know is how much strontium-90 are you going to have after 152.4 years, okay? So the first thing you have to do is you have to figure out how many half-lives is 152.4 years. Then you're going to take the 36 milligrams, and then you're going to use the half-lives to figure out how much you'll have left after that number. Okay, so the quality for this is 1 half-life for strontium-90 is equal to 38.1 years. So remember, our conversion factor can go top or bottom. So 1 half-life of strontium-90 is equal to 38.1 years. Except we have 152.4 years, right? So 152.4 years times the conversion of 1 half-life to 38.1 gives you 4 half-lives. Now, in order to figure out how many milligrams you have, you take half of 36 the first time, which gives you 18. Then you take half of 18. Okay, so we had 36 divided by 2. Then we have 18 divided by 2 gives you 9. Then 9 divided by 2 is 4.5. 4.5 divided by 2 gives you 2.25 or 2.3. So that's 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives. So our answer would be 2.3 milligrams of strontium-90 after 152.4 years if we started with 36. All right, so here's a learning check, and in this one we're using carbon-14, and if you see, any of those shows where they're, trying to find Holy Land stuff or, prove something, Noah's Ark or whatever, they use carbon-14 a lot of times, or they used to, and so they did use it when they were trying to determine the age of the Dead Sea Scrolls when they were first discovered. And so they determined that they were 2,000 years old, and the half-life of carbon-14 is 5730 years. What fraction of the half-life has passed? All right, so you're given what? You're given that you have 1 half-life is the same as 5730 years. All right, you're given the age is 2,000 years. And so what are they wanting to know? They're wanting to know what fraction of this half-life has passed. And so to do that, you say, well, I've got 2,000 years. And I know that yours has to go down there, that there's 5730 years in 1 half-life. And so the fraction of that would be 0.35 half-lives. Okay, which is 35%. Okay, so 35% of that has decayed. Here's another one. Put me on hold and see if you can do this one. The half-life of I-123 is 13 hours. Okay, so over here, 1 half-life is the same as what? 13 hours. That's a nice short one, isn't it? You've got 64 milligrams of it, and you've got 26 hours that it's going to be in there. So how much will be left after 26 hours, right? Well, what you've got, what you can hold in your hand, is 64 milligrams of I-123, right? And so you've got your conversion factor that you can use. You know that if you've got 13 hours in 1 half-life and you've got 26 hours, then that's going to give you how many half-lives? 2, right? It's because you have to figure out the half-lives. Okay, so you've got 2 half-lives. So 64 milligrams. Let's just do it like this. 64 milligrams. We're going to take half of it. Half of 64 is 32. Okay, that's the first half-life. And then the second half-life, you take half of 32. So Alright, so this is the first one, this is the second one. So after 2 half-lives, we would have what? 16 milligrams. Okay, so you figure out your half-lives first, and then you take your milligrams and you just put them in and figure out how much you would have left after you halved them this many times. And that's it. Not too bad, is it? And that is it for chapter 9, or section 9.4 of chapter 9. And that is half-lives.